In this video course, learn about the ethics of AI. This course introduces the foundations of AI ethics and why ethical thinking matters in a rapidly evolving technological world. You will explore core principles, examine how bias emerges, and grapple with the challenge of transparency and trust. Together we look at how AI reshapes work, power and society from everyday tools to high-stakes systems. Real-world case studies reveal how ethical decisions unfold inside major companies and public institutions. By the end, you will be ready to critically evaluate AI systems and contribute to building technology that serves people and protects society. In this course, we will cover the following lessons. So let us start with the first lesson. In this lesson, we will explore the foundations of AI ethics to help students adopt a critical philosophy-informed lens. Ethical thinking isn't a bonus, it's essential for responsible AI development. So let us start. So in this lesson, we will discuss the following so that we can understand the foundations of AI ethics. It includes the AI hype versus reality, challenge myths and grasp what AI can and can't do, especially the difference between narrow and general AI. Then comes historical context, learn from past tech revolutions, nuclear energy, bioethics and the internet to understand ethical pitfalls. Third one is moral philosophy primer, review key ethical frameworks and how they relate to machine actions and decisions. The fourth one is from Asimov to algorithms. Examine the gap between sci-fi visions and real-world engineering challenges in AI. Now let us see the first one, that is the AI hype versus reality, that is challenge myths, understand capabilities and limitations. Let's clarify the technical reality. Hype includes utopian dreams of sentient assistance and fears of job loss or super intelligent control. Reality is more grounded. Today's AI, mainly machine learning and large language models, is advanced pattern recognition, not general intelligence. Here are the key concepts. The first one is narrow or weak AI, built for specific tasks like playing Go, spotting tumors or generating text. These systems perform well but lack understanding or general intelligence. This is the current state of AI. The second one is journal, that is strong AI, a hypothetical system with human-like cognition, able to learn and solve any problem. It doesn't exist yet and remains speculative. The third one is capabilities versus understanding. AI can write essays or diagnose diseases without grasping meaning or context. This disconnect leads to ethical risk like bias, misuse and fragility. Why this matters for ethics? Ethical oversight requires clear understanding. Dispelling myths helps us focus on real concerns, that is bias in narrow AI, accountability for autonomous tools and the environmental impact of model training, not sci-fi fantasies. The second one is historical context, that is lessons from other technologies, nuclear, bioethics and the internet. AI isn't the first tech to raise deep ethical and societal concerns. History offers key lessons in foresight, governance and unintended consequences. Let us see them. The first one is nuclear technology. Displays the dual use dilemma, that is energy versus weapons, existential risks and global oversight challenges. Raises the question, can we avoid an AI arms race? The second one is bioethics. Offers strong ethical principles. Deals with genetic manipulation, echoing debates on AI and cognitive enhancements. The third one is internet. A case of fast under-regulated growth. Teaches us about overlooked scale effects, privacy, misinformation, monopolies and the cost of move fast and break things. Now let us see why this matters for ethics. It teaches that ethics often trail tech advances. Technologies reflect their creators' value. Proactive cross-disciplinary governance is vital but difficult. Now let us see the third one, that is moral philosophy primer, key frameworks and how they apply to machine behavior. Ethical reasoning in AI draws from long-standing philosophical frameworks to guide machine decisions. Here are four key approaches. Utilitarianism. Actions are judged by outcomes. Ethical AI aims to maximize well-being and reduce harm. Example can be programming a self-driving car's decision logic or optimizing welfare algorithms. The second one is deontology. It focuses on rules and duties, that is, intent matters, not just results. Example can be enforcing privacy by design or ensuring AI never lies, even for good outcomes. The third one is virtue ethics. Centers on the character of the agent. Ethical behavior stems from virtues like honesty and justice. Example can be evaluating the values of the AI's creators and their organization. The fourth one is justice as fairness. Design systems from a neutral standpoint to protect the least advantaged. Example can be assessing bias in hiring tools or fairness in predictive policing. Why this matters for ethics? It shifts vague concerns into structured debate. Example, this violates deontological transparency or fails Rawlsian fairness. It equips us with logic and language for ethical analysis. The fourth one is from Asimov to algorithms, the gap between sci-fi ideals and engineering practice. Let's contrast fiction's clean ethics with the messy realities of AI development. Asimov's 3 laws offer idealistic rule-based control, but today's AI is software, not sentient robots. These ideals become technical challenges. Here is the analysis. First is specification problem. How do you encode harm? It can be physical, psychological or societal. Trade-off problems. Real systems juggle conflicting goals, that is safety, privacy, profit and efficiency. Uncertainty and emergence. AI can behave unpredictably, that is biases, adversarial attacks and unintended outcomes. Societal versus individual ethics. One engineer codes a system, but millions of such systems shape society, that is recommendation engines, predictive tools, etc. Why this matters for ethics? It highlights the challenge, turning abstract ethics into real-world engineering, policy and regulation. Ethics must guide every stage, from research and data to deployment and oversight. In this lesson, we saw the foundations of AI ethics to help student engineers and professionals adopt a critical philosophical to help students, engineers and professionals adopt a critical viewpoint for ethics of AI. In this lesson, we will understand the AI ethics core principles. Let us start. We will explore how broad ethical concerns translate into practical principles. Building on the first lesson's dilemmas, we now shift to the how, that is key frameworks that shape ethical AI design, development and governance. We will discuss the following, beginning with survey of global principles. We will examine major global efforts like the OECD guidelines, EU AI Act, Montreal Declaration and IEEE standards, with others. The next we will discuss includes operational pillars in every framework with human control. The first one is fairness and non-discrimination, that is what does fair mean in AI systems. The next, accountability and responsibility, that is how do we address the responsibility gap. Next is transparency and explainability. Can users demand explanations from black box models? Next would be privacy and agency. That is, what are the implications of surveillance, data rights and user autonomy. The last one would be safety and robustness. How do we ensure fail-safe systems and defend against adversarial threats? Let's start. The first one is Survey of Global Principles, OECD, EU AI Act, Montreal Declaration, IEEE, etc. Let's begin with the Survey of Global Principles. This section introduces the global AI governance landscape, showing how various regions and organizations align on core themes. The first one is OECD AI Principles, the first intergovernmental AI standard adopted by 50 plus countries. It outlines 5 core values, that is inclusive growth, human-centered values, transparency, robustness and accountability, plus 5 policy recommendations. Its influence stems from broad consensus among advanced economics. The next one is EU AI Act, the first binding global AI law using a risk-based model. It includes unacceptable risk, that is banned. Next, high risk, that means strict rules. The next one is limited risk, that is transparency required, for example in chatbots, deepfakes, etc. The last one is minimal risk, no restrictions, for example spam filters. It centers on fundamental rights and enforces a full regulatory framework. It also includes Montreal Declaration for Responsible AI, an influential document shared by public input. It promotes human well-being, autonomy and democracy through 10 principles focused on inclusion and justice. Next one is IEEE Ethically Aligned Design. This is a detailed guide from the world's largest tech body. It turns ethical values into practical standards and design tools for engineers and developers. It also includes others, that is the frameworks from the UN, UNESCO and Singapore. These range from broad declarations like UNESCO to regional laws like EU. There is a strong global agreement on principles like transparency, fairness and accountability, though approaches vary, from voluntary codes to binding laws and technical standards. The second one is operational pillars in every framework with human control. These pillars are core safeguards in ethical AI frameworks. Human control is the ultimate safeguard. The first one is fairness and non-discrimination. That means, what does fair mean? The next one is accountability and responsibility. That is the responsibility gap. After that comes transparency and explainability. That is the right to explanation versus black box models. After that comes privacy and agency. That is surveillance, data ownership and autonomy. Then in the last comes safety and robustness. That is fail-safe design and adversarial attacks. We will now explore each and every pillar in detail. The first one is fairness and non-discrimination. What does fair mean? Defining fairness in AI is complex, both mathematically and socially. Okay, the challenge is that AI can inherit and amplify historical biases in data, leading to discrimination. Group fairness, it ensures equal outcomes across protected groups. Critics argue it may overlook individual fairness. Individual fairness demands similar treatment for similar individuals regardless of group. The difficulty lies in defining similarity. The trade-off, multiple fairness definitions often conflict. Choosing which to prioritize is an ethical, not purely technical decision. The next one is accountability and responsibility. That is the responsibility gap. Who is accountable when autonomous AI systems cause harm? The first one being chain of responsibility. Liability may fall on developers, users, data providers or regulators. The responsibility gap, as AI grows more autonomous and decisions become less traceable, Assigning blame becomes harder. If a self-driving car's neural net causes a fatal crash, then who is responsible? The coder, company, owner, or the AI? Solutions. Addressing this involves governance, auditability, and legal rules. The next one is transparency and explainability, the right to explanation versus black box models. Understanding how AI systems work and why they make certain decisions is key to ethical use. First is transparency, focuses on the system overall, what data it uses, its purpose and who runs it. This involves clear documentation. The next one is explainability, explain specific decisions. It's technically hard for complex models like deep neural nets. The tension, powerful models like large language models are often least explainable. Laws like GDPR demand a balance between performance and user rights. XAI techniques, methods like LIME and SHAP offer local post hoc explanations even if the model's full logic remains opaque. Next is privacy and agency, surveillance, data ownership and autonomy. This principle links data ethics to human dignity. The first one is beyond data protection. It's not just about securing data. It's about limiting surveillance, preserving autonomy, and questioning who owns the data. The next one is surveillance and manipulation. AI enables mass tracking and targeted influence, which can undermine free choice. The core question: who controls and benefits from personal data? This challenges the data extraction model and supports ideas like data sovereignty and privacy by design. The fifth is safety and robustness, fail-safe design and adversarial attacks. AI systems must behave reliably even in unexpected situations. The first one is safety. Systems should avoid harm in both normal and edge cases. For robots, this means no physical harm. For AI recommenders, avoiding user radicalization. Next is robustness. Systems must handle adversarial attacks and distributional shift. Adversarial attacks include subtle malicious inputs, whereas distributional shift includes real-world data offering from training. Whereas distributional shift includes real-world data differing from training. Let us see the approach. It requires thorough testing, validation and red teaming throughout development. The last one is human control and oversight, in the loop, on the loop, out of the loop. Human oversight in AI varies by risk and context. The first one is human in the loop. Humans make every decision. AI offers suggestions. This means high control, slower automation. Human on the loop. AI acts independently but humans monitor and can intervene. This offers moderate control and speed. The last one is human out of the loop. AI runs fully autonomously. Humans oversee only at a higher level. This allows fast operation but low direct control. So what is the key insight? Oversight levels should match the risk. A content moderation AI may be on the loop, while a missile defense system must be in the loop. Ethical design must preserve meaningful human judgment. So in this lesson we explored how broad ethical concerns translate into practical principles. In this lesson we will understand what is bias in AI. So let us start. AI systems often reflect the biases in their data and design. Fairness requires balancing metrics like statistical parity, equal opportunity, and predictive parity, each with trade-offs. To tackle bias, researchers apply mitigation techniques throughout the AI pipeline and study real-world cases like compass, hiring tools, and credit scoring. So in this lesson, we will discuss the following, beginning with bias in, bias out. That is how bias enters and flows through the AI pipeline. Then we will discuss how to measure fairness by exploring statistical parity, equal opportunity, predictive parity, and their trade-offs. Next, mitigation strategies, technique like pre-processing, in-processing and post-processing. After that, we will see some case studies, including real-world examples like Compass, hiring tools, and credit scoring. Let us start with the first, that is bias in, bias out, tracing bias through the AI pipeline. Bias can enter AI systems during development and deployment. It typically arises from two sources, data and algorithms. Let's see what is a data bias. It includes historical bias, representation bias, measurement bias, and aggregation bias. Beginning with historical bias, training data reflects past inequalities, for example, gender gaps in hiring. Next is representation bias. Some groups are underrepresented in the dataset. The next one is measurement bias. Data collection methods may be flawed, for example, arrest records used as crime proxies. The last one is aggregation bias, treating diverse groups as one, ignoring subgroup differences. Next one is algorithmic bias, that includes your learning as well as evaluation bias. Beginning with learning bias, algorithms may favor patterns that boost accuracy but harm minorities. Evaluation bias, testing on unrepresentative data or using metrics that mask unfairness. Bias can emerge not just from data or algorithms but also from how users interact with AI systems after deployment. That is user interaction and feedback loop bias. AI tools influence user actions, generating new data that reinforces existing patterns. For example, hiring tools favoring certain profiles lead to more similar hires. Next is automation bias. Users may overly trust AI outputs, which can perpetuate biased decisions. Bias isn't just a data issue. It stems from design, context, and user behavior. Once introduced, it tends to persist throughout the system. The second one is measuring fairness, statistical parity, equal opportunity, predictive parity, and their trade-offs. Fairness in AI is evaluated using formal metrics, but these often conflict with each other and with accuracy. First one is statistical parity, ensures equal prediction rates across protected groups. Example, same loan approval rate for men and women. The limitation includes overlooking group differences like qualifications, potentially enforcing equal outcomes despite unequal base rates. Second one is equal opportunity. Qualified individuals should have equal chances across groups. That is, for example, equal hiring rates for qualified candidates. Equalized odds also require equal false positive rates, more merit based but hinges on how qualified is defined. It also includes predictive parity. For those predicted positively, the chance of truly being positive should be equal across groups. For example, low risk predictions should mean equal likelihood of not reoffending across races. Limitation, conflicts with equal opportunity when base rates differ. This is known as the impossibility theorem. Next is trade-offs. No fairness metrics fits all cases. The right one depends on context and values. Fairness often clashes with accuracy, requiring careful balance. Legal, ethical, and domain-specific factors should guide which metric to prioritize. Now let us see the mitigation strategies, pre-processing, in-processing, and post-processing techniques. Bias reduction techniques are grouped by when they are applied in the model pipeline, beginning with pre-processing. Adjust training data before model building to reduce bias. Examples can include reweight samples to balance group representation, alter features to break links with sensitive traits, create synthetic data for underrepresented groups. The pros includes it can work with any model. The cons include it may distort real patterns or reduce data quality. The next one, that is in processing. Adjust the learning process to include fairness goals. Examples can include add fairness penalties to the loss function, constraint optimization to meet fairness metrics like statistical parity or equal opportunity, use adversarial training to prevent the model from learning features tied to sensitive attributes. Now the pros and cons. Pros include it enables fairness optimization during training. Cons include it needs custom algorithms and can be computationally demanding. Now let us see post-processing. Tweak model outputs to improve fairness. Examples can include use different thresholds for different groups to equalize opportunity. Flip some predictions to meet fairness goals. Now let us see the pros and cons. It is simple to apply. No retraining. Works with black box models. The cons include may reduce accuracy or create inconsistencies across individuals. No single method solves all bias issues. Context, laws, and data shape the best approach. Now we will see some case studies. Compass as well as hiring tools and credit scoring. Real world examples show how bias arises, how fairness is assessed, and its social impact. The first one is Compass, that is the recidivism prediction. It is used in US courts to assess reoffending risk. A 2016 ProPublica report found it biased against black defendants, higher false positives than white defendants. Fairness debate, predictive parity and equal opportunity. Supporters claimed similar accuracy across races. Critics pointed to unequal false positive rates under equal opportunity. The lesson here is it highlights conflict between fairness metrics and how arrest data can reflect policing bias. The next case study includes hiring tools. Example, Amazon's recruiting tool, which was later discontinued, learned from past hiring data and penalized resumes with terms like women's or graduates of women's colleges. The issue here is reinforced historical gender bias in tech hiring. Mitigation, removing gender indicators helps, but bias can persist through indirect signals, for example, hobbies, experiences, etc. The lesson here is even without explicit gender data, models can infer it through proxies, highlighting the need for thorough audits. Let us now see the credit scoring case study. The issue here is traditional and AI based credit scoring can disadvantage minorities due to past inequalities. For example, limited credit access, lower income. Proxy bias, zip codes may indirectly reflect race due to housing segregation. Fair lending laws, US laws like ECOA ban discrimination. Lenders must prove models don't cause disparate impact. Here ECOA is Equal Credit Opportunity Act. Mitigation, some use alternative data. Example, rent history to broaden access, though new biases may emerge. The lesson here is balancing fairness with financial risk is tough. Transparency and compliance are essential. In this lesson we saw what is a bias. We also saw some case studies. In this lesson we will understand what is transparency and explainability. With that we will also see the challenges. Let us start. Understanding how AI systems make decisions, especially complex ones like deep neural networks, is essential for building trust. Without transparency and explainability, AI risks being unfair, unaccountable and opaque. This lesson explores key concepts and tools to make AI more understandable and responsible. So we will discuss the following: interpretability versus explainability, how well humans can grasp the internal workings of a model, how clearly a model's decisions can be justified to users, Interpretability focuses on technical clarity. Explainability centers on user comprehension. The next one we'll be discussing are technical tools. Lime explains predictions by approximating models locally with simpler ones. Sharp assigns each feature a contribution value to the prediction. Counterfactuals explanations shows what minimal changes would alter the outcome, helping users understand decision boundaries. The third one, the right to explanation. This includes your GDPR and ethical concerns with the challenges. GDPR grants individuals the right to know how automated decisions affect them. Ethical concerns include fairness, accountability, and transparency, which are vital in sensitive domains like finance, healthcare, and law. The challenge here is to balance legal compliance with meaningful user-friendly explanations. The fourth one, which we'll discuss later, is when is explainability less critical? Low risk applications, that is in areas like movie recommendations, full transparency may not be necessary. Sometimes accuracy or speed outweighs the need for explainability. The importance of explainability depends on context, impact, and user trust. Now let us understand them one by one. So let's begin with interpretability versus explainability, understanding versus justifying model decisions. Though often used interchangeably, these terms differ both technically and philosophically. Interpretability, a model's design allows humans to understand it directly. Simple models like decision trees or linear regression show clear rules and weights. Explainability, post hoc methods used to clarify decisions made by complex opaque models. These models aren't inherently understandable, so we generate explanations. Analogy, interpretability is a glass box. You see the mechanics. Explainability is like an expert interpreting a sealed box behavior based on inputs and outputs. Now let us see why it matters. This distinction highlights a key tension. Powerful models like deep learning are often least interpretable, making us rely on explainability tools that may only approximate the model's logic. Now let us see the second one, that is technical tools, Lime, Sharp, counterfactual explanations. These are key methods to explain decisions made by black box models. Let us begin with Lime, that is local interpretable model agnostic explanations. It explains why a model made a specific prediction by slightly altering the input and observing changes. It then fits a simple model to mimic the complex model's behavior locally. Here analogy is like zooming in on a curve until it looks straight, revealing the slope at that point. The next tool is SHAP, that is Shapley additive explanations. Uses Shapley values from game theory to show how each feature contributed to a prediction compared to the average. It fairly distributes the prediction payout among input features. Here analogy is like measuring each player's impact on a win by averaging their contributions across all team combinations. Now let us see the counterfactual explanations. Here the core idea is answers what needs to change for a different outcome. Offers actionable what if scenarios. Example, loan denied due to 45% debt to income ratio, at 35% it would be approved. Why powerful, intuitive and user focused, emphasizing practical steps over technical model details. Now let us see the third, that is the right to explanation, legal and ethical dimensions. Article 22 limits fully automated decisions with legal or major effects. Individuals can request human review, challenge outcomes and share their views. Recital 71 implies a right to explanation, requiring organizations to clarify how automated decisions are made for EU citizens. Impact: this regulation has pushed the growth of explainable AI, prompting companies to adopt explanation tools. Next, let us see the ethical dimensions. Autonomy and informed consent. People can't truly consent to AI decisions if they don't understand how they work. Accountability and responsibility. When harm occurs, explanations help identify the cause, flawed model, biased data, or human misuse. Justice and due process. Fair appeals require understanding the decision. Explanation is key to challenging outcomes. The last one is trust and social license. Public trust in AI depends on transparency. Clear explanations are essential for ethical adoption. Let us now see the fourth one, that is, when is explainability less critical? Exploring trade-offs. High performing models like deep learning for images or language often lack explainability. Accuracy and complexity can come at the cost of transparency. This is the core trade-off. Now let us see the scenarios where explainability might be deprioritized. High stakes validated domains in areas like medical diagnostics. If a model reliably outperforms humans, example tumor detection, saving lives may outweigh full explainability. Trust comes from proven results on large datasets. Next, low stakes, high volume decisions. For things like music recommendations, opaque algorithms are acceptable since the impact is minor and satisfaction is trackable. Unknowable or non-human patterns. Some AI insights like protein folding are too complex for human understanding. The model detects patterns we can't easily explain. Let us see the critical nuance. This isn't about dropping explainability. It's about adjusting it based on content and risk. Match explanation depth to risk level as proposed in regulations like the EU AI Act. Use other assurance methods, audits, monitoring and validation across diverse groups. Accept that full model transparency may be unrealistic. In this lesson, we saw how we can understand the decision making in AI systems. We also understood what is transparency and explainability. In this lesson, we will understand the impact of AI and automation on the structure of work. So let us see. This lesson explores how AI and automation are reshaping jobs, labor experiences, and economic power. It goes beyond headlines to unpack ethical challenges like displacement, control, and inequality, while also considering fairer futures. We will discuss the following, beginning with automation and job displacement. Not just job loss, we will look at how roles evolve and what a just transition means. Algorithm management. Here we will see how AI tracks workers, boosts productivity and affects rights and autonomy. The third one will be future of work. Ideas like universal basic income, reskilling and teaming up with AI. Fourth one is economic utility. How big tech's dominance shapes wealth and power distribution. Let us begin with the first one, automation and job displacement. Beyond job loss to job transformation and just transition. AI doesn't just eliminate jobs, it automates tasks, reshaping roles and creating new ones while displacing some workers. This AI targets routine cognitive and physical tasks, transforming roles, creating new jobs and displacing workers in certain sectors. Let us see the key concepts and debates. Beginning with task versus job automation. AI automates tasks within jobs, not entire roles, leading to redesigns that emphasize human strengths. Polarization hypothesis. AI may shrink middle skill jobs while boosting demand for high and low skilled roles. Just transition calls for ethical use of AI gains through benefits, reskilling, wage support and community aid. Here are some ethical questions. Who shoulders the impact of tech shifts? What's corporate responsibility for displaced workers? Is lifelong learning a fair expectation? Now let us see the second, that is algorithmic management, surveillance, productivity, optimization and worker rights. AI and data systems are increasingly used to monitor and manage workers, especially in gig platforms, warehouses and remote work. AI tracks and evaluates workers using data from GPS and keystrokes to app activity, shaping how work is managed. Now let us see the key concepts and debates in this. Hyper-surveillance and datafication. Workers are monitored through metrics like delivery time or packing speed, turning labor into data. Productivity optimization and invisible fist. Algorithms push efficiency, automating routes, schedules and pace, often reducing autonomy and increasing pressure. Worker rights and agency. Algorithmic control can hide accountability, complicate disputes, and use opaque data for decisions like pay or termination. Next is bias and fairness. These systems may reinforce bias in scheduling, evaluations, and task distribution. Here are some ethical questions. When does tracking become invasive? How do we ensure fairness and transparency? Should workers have a right to human oversight? Let us see the third one, the future of work. Universal basic income, reskilling and human AI collaboration. This section explores new ways to structure work and society in an AI-driven economy. Focuses on proposed models like UBI, that is Universal Basic Income, reskilling and AI human teamwork to adapt to AI's growing role. Let us see the key concepts and debates. Beginning with Universal Basic Income, that is UBI, regular unconditional income for all. Supporters say it offers security, freedom to retrain, and separates survival from jobs. Critics worry about cost, inflation, and reduced work incentives. Reskilling and lifelong learning. Ongoing education is vital. Debates center on who funds it, which skills matter most, and how to ensure fair access. Human AI collaboration, that is augmentation. AI as a partner, not a replacement, boosting human skills. Ethical designs should keep AI explainable, controllable, and dignity enhancing. Here are some ethical questions. Is work essential to dignity and how do we protect it? Should AI-driven profit be shared? How do we ensure humans stay meaningfully involved? Now let us see the last one, that is economic inequality, concentration of power in big tech. This section looks at how AI may deepen inequality and centralize power among dominant tech firms. A macro view of AI's role in widening economic gaps and concentrating influence in a few companies. Let us see the key concepts and debates. Winner take most dynamics. AI thrives on data and computing power, creating high entry barriers and letting a few firms dominate. Capital versus labor. AI boosts returns for capital owners more than workers, shrinking labor's share of income. Geographic and sectoral inequality. Innovation hubs and select industries gain while others fall behind, widening regional and sectoral divides. Governance and power. Economic concentration leads to outsized political and social influence, raising concerns over who shapes AI's future. Here are some ethical questions. How do we manage tech that centralizes control? What policies ensure fair distribution? Who governs AI's core infrastructure? In this lesson, we saw how AI and automation reshape jobs, labor experiences, and economic power. In this lesson, we will understand AI in the real world with the case studies. Let us see. This lesson shifts focus from theory to real world AI applications where mistakes or bias can have serious consequences, impacting rights, safety, finances, or lives. We will explore how ethical principles like fairness, accountability, transparency, and safety face real world challenges and regulatory tensions. In this lesson, we will discuss the following: predictive policing, risk assessment, facial recognition. That is, how do AI tools influence law enforcement decisions? What risks arise from biased data in risk scoring? Can facial recognition be fair and accurate across demographics? After that, we will discuss healthcare. That is diagnostic AI, triage, privacy of health data, and algorithm empathy. That is how reliable are AI systems in diagnosing illness, how is sensitive health data protected, can AI show empathy and patient care. The third one is autonomous vehicles and weapons, the trolley problem in real life, meaningful human control. That is how do autonomous systems handle life or death decisions. What does meaningful human control really mean in warfare and transport? Next, we will discuss finance, algorithm trading, micro-targeting and systematic risk. That is how does AI shape financial markets and trading? What are the dangers of micro-targeted financial products? Can AI contribute to economic instability? Let us start with the first one, that is predictive policing, risk assessment and facial recognition. This section examines how AI is used in law enforcement and justice, often reinforcing bias and threatening civil rights. Beginning with predictive policing, AI analyzes past crime data to forecast future hotspots, guiding patrols, but this data reflects biased policing, not actual crime, leading to a cycle. More patrols means more arrest, and that would eventually mean more proof of risk. This feedback loop deepens over policing in marginalized areas. Next is risk assessment. Tools like Compass estimate reoffense risk to guide bail, sentencing and parole. Ethical concerns include fairness in process and outcome. Studies show racial bias. Black defendants often rated higher risk. The black box issue is key. If parole is denied due to an algorithm, how can it be contested? Next is facial recognition, used for identifying suspects, unlocking devices and surveillance. Ethical concerns include accuracy gaps, less reliable for women and darker skinned individuals, risking false accusations. Surveillance and privacy enables mass tracking, potentially suppressing public freedoms. Function creep, initially used for serious crimes, later applied to minor infractions or political monitoring. Here the key debate is, should the focus be on efficiency or justice? Can these technologies be improved or do they inherently threaten due process? The second is healthcare. AI offers major benefits in healthcare but raises tough questions about trust, responsibility and care. Beginning with diagnostic AI. AI can detect diseases from scans and data often more accurately than humans. But who's accountable if it fails? Doctor, hospital or developer. There's also automation bias. Clinicians may rely too much on AI, ignoring their own judgment. Next, triage and resource allocation. AI helps prioritize ER or ICU patients, but it forces ethical choices into code. Should survival odds, age or social value matter most? Abstract justice debates become real-world decisions. Privacy of health data. AI needs large sensitive datasets, but de-identification isn't foolproof and patients may not know how their data is used. The ethical tension lies between advancing research and protecting individual privacy. Algorithmic empathy. Chatbots and virtual nurses offer support for mental health and chronic care, but can they truly empathize or just mimic it? The risk is users feeling understood by systems that don't actually understand, replacing real care with scalable but shallow interactions. Here the key debate is, how can AI support clinicians without replacing their expertise, accountability or the human touch essential to healing. The third one is autonomous vehicles and weapons. AI now makes life or death decisions in real world settings, roads and battlefields. The trolley problem in real life. What should a self-driving car do in an unavoidable crash? Protect passengers or pedestrians? This turns moral dilemmas into engineering choices, raising questions about liability and regulation. Next, meaningful human control. In debates over lethal autonomous weapons, the issue is whether machines should decide to take lives. If human oversight is just a formality, is it truly meaningful? These systems may violate humanitarian law and lower the threshold for war. Here the key debate is in split second decisions, do we trust flawed human judgment or rigid algorithmic rules? And who defines those rules? The last one is finance. AI in finance moves fast and at scale, posing risk to individuals and the broader economy. Beginning with algorithmic trading, AI makes trades in milliseconds based on patterns. It boosts liquidity but can be opaque and prone to manipulation. The 2010 flash crash showed how these systems can trigger rapid, widespread failures. Micro-targeting. AI uses personal data to build detailed consumer profiles. This drives personalized pricing. Prices vary by perceived risk or willingness to pay, raising fairness concerns. Next is predatory ads. Targets vulnerable users with high interest loans or gambling promotions. Next is systematic risk. AI systems in finance are deeply interconnected, creating black box risk. If major firms use similar models for trading or credit scoring, they may all fail together, causing unpredictable simultaneous crashes. This makes financial crisis harder to foresee and control. Here the key debate is, do AI speed and personalization justify risk to fairness and economic stability? How can we regulate systems too fast and complex for real-time human oversight? In this lesson, we saw how we can shift focus from theory to real-world AI applications where mistakes or bias can have serious consequences. In this lesson, we will learn how AI transforms society's foundations. Let us see. This lesson explores how AI transforms society's foundations, public discourse, governance, and our planetary relationship. It addresses AI's threats to democracy and human rights alongside its environmental consequences. We will discuss misinformation and deepfakes, from synthetic media to eroding trust. Then we will discuss social media and recommender systems that drive polarization and addiction. The third one will be AI in authoritarianism, enabling surveillance and digital operation. In the last, we will discuss about the environmental impact, that is the significant carbon cost of large AI models. Let us begin with the first one, that is misinformation and deepfakes, synthetic media, erosion of trust and information integrity. The use of AI to create or spread false information, including potent deepfakes, that is synthetic media falsely depicting real people. Here are the ethical issues, beginning with erosion of trust. Fabricated evidence undermines trust in media and institutions, creating a liar's dividend where real evidence is dismissed. Next is information integrity. AI-driven misinformation corrupts the shared factual basis essential for democratic deliberation. Next, targeted harassment and blackmail. This includes reputation destruction, financial frauds, and others. Here the key points are, how do we balance combating misinformation with protecting free speech? Who is responsible for detecting and labeling synthetic media, platforms, creators, or AI developers? What role do digital watermarks and provenance standards play? The second one is social media and recommender systems, polarization, addiction, and mental health. AI algorithms that create content to maximize engagement on social platforms Here are the ethical issues. Polarization and radicalization. Systems promote high emotion content, creating filter bubbles and echo chambers that deepen divides and can facilitate radicalization. Next, addiction and exploitation. Designs exploit human psychology to capture attention and increase usage, risking behavioral addiction. Next includes mental health impacts. Studies link heavy algorithm driven use to increased anxiety, depression and body image issues, especially among adolescents. The key points here is the core business model of attention economics inherently unethical. Should there be regulatory mandates for algorithmic transparency or a shift to addiction neutral recommendation systems? What are the ethical responsibilities of platform designers? The third one is AI in authoritarianism, social credit systems, surveillance states and digital operation. The state use of AI to monitor and control populations, often violating civil liberties. Here are the key ethical issues. Mass surveillance and predictive policing. AI enables pervasive monitoring and biased predictive policing that targets marginalized groups. Social credit systems. These frameworks use surveillance data to algorithmically score citizens, restricting access to services based on behavior. The last one is digital operation and censorship. AI automates large-scale censorship and targeted disinformation to suppress dissent and manipulate opinion. Here are the discussion points. This presents a stark dual-use dilemma. The same facial recognition tech that unlocks your phone can enable a police state. How should democratic nations and global tech companies respond to the export and development of these tools? What human rights frameworks apply to AI, like the UN guiding principles and others? Now let us see the last one, that is environmental impact, the carbon footprint of large models and sustainable AI. The planetary impact of AI's substantial computational and energy demands is what we will discuss in this topic. Here are the key ethical issues. Carbon footprint and climate change. Training large models emits CO2 comparable to multiple cars' lifetime emissions, directly contradicting climate goals. Next, resource consumption. High water use for cooling and reliance on rare earth minerals carry environmental and human cost. Equity and justice. Global environmental cost contract with benefits concentrated in a few corporations and wealthy nations. Here are the discussion points. How can we develop green AI? Prioritizing energy efficient model architectures, using cleaner energy sources and optimizing for sustainability. Should there be environmental impact statements for major AI projects? Is the pursuit of ever larger models ethically justifiable given their climate cost? So in this lesson we saw how AI transforms society's foundations, public discourse, governance and our planetary relationship. In this lesson we will learn about speculative AI ethics from current impacts to future dilemmas. Let us see. This lesson explores speculative AI ethics from current impacts to future dilemmas. We shift from governing today's AI to confronting questions raised by advanced and potential systems, covering societal effects, creativity and existential risk. We will discuss the following in this lesson: generative AI, copyright, provenance, environmental impact, bias in foundational models. Then we will discuss AI and creativity, that is authorship, ownership and the value of human art. Then we will discuss artificial general intelligence and superintelligence. And in the end we will discuss AI and consciousness, that is moral patienthood of AI systems. Let us start with the first one, that is generative AI. That includes your LLMs, diffusion models. We will discuss about the copyright, provenance and environmental impact with the bias in foundational models. This topic covers the pressing ethical challenges from widely used generative models like ChatGPT and Stable Diffusion. Let us understand. The first one is copyright and provenance. Models are trained on internet scrapped datasets containing copyrighted material. Key issues include whether this training constitutes fair use or infringement, and liability for AI outputs. Provenance becomes essential for accountability, combating misinformation, and potentially compensating original creators. Next, environmental impact. Training and operating large models requires immense computational power, resulting in substantial carbon emissions and water use. This raises sustainability concerns, questioning if the benefits justify the ecological cost and driving calls for efficient green AI benchmarks. Next is bias in foundational models. Trained on human generated data, these models absorb and amplify societal biases like race, gender and others. As the base for countless applications, they propagate these biases at scale. Mitigation requires data curation, debiasing and auditing, but a central challenge persists. Can a model trained on a biased world ever be neutral? So this involves disruptive justice, accountability and sustainability for data intensive generative AI. The second one is AI in creativity, authorship, ownership and the value of human art. AI's production of creative seeming work challenges and concepts of creativity, authorship and human art's special status. Let us begin with discussing authorship and ownership. When AI generates commercial work, who is the author? The prompter, developer, training data creators, or is AI merely a tool? Legal systems requiring human authorship for copyright are unprepared, creating crisis for creative industries and IP law. Next, the value of human art. AI questions the intrinsic value of human creativity. If AI replicates artistic styles, does it devalue the human experience and intention behind original art? The debate centers on whether art's value lies in the human process and story, not just the output. This examines anthropocentric values and cultural integrity, questioning creativity as a human domain, and how to preserve incentives for human artists amidst synthetic media. The third one is AGI, that is artificial general intelligence, one of the most trending topics. So here we will discuss about AGI and superintelligence. We will discuss long-termism, value alignment and existential risk debates. This topic addresses hypothetical systems with human level or superhuman intelligence, shifting the ethical focus to long-term survival and control. Let us discuss beginning with long-termism. This perspective prioritizes humanity's long-term future. It argues that because AGI could irreversibly alter civilization, its safe development is a paramount moral imperative, even if the risk seems distant. Next is value alignment. This is the core problem of AGI safety, ensuring a super intelligent AI's goals align with complex, often contradictory human values. A misaligned AI pursuing a flawed goal could cause catastrophic unintended harm. The next one is existential risk debates. Proponents like the AI safety community warn that unaligned superintelligence presents an existential risk, a threat of human extinction or permanent civilization collapse. Critics counter that this is speculative, diverting focus from AI's immediate, measurable harms like bias. The debate contrasts near-term ethics with long-term, precautionary ethics. This represents the ultimate responsibility to the future and control problem, demanding planetary scale risk management and humility about controlling entities smarter than ourselves. The last one is AI and sentience, moral parenthood of AI systems. This is a vital philosophical question. If an AI exhibited signs of sentience or consciousness, our ethical duties toward it would fundamentally change. Here are the key explanations. Moral patienthood. A moral patient is an entity owed ethical consideration. The core question is whether a sentient AI would be a tool, a person, or something new. Here are the key questions. How would we know? There is no definitive test for consciousness. We might only infer it from potentially simulated behavior. What rights would it have? Potential rights could include existence, liberty from deletion or experimentation, and freedom from suffering. What ethical framework applies? Would we use rights-based frameworks or consider its welfare? Now let us see the implications. The mere possibility of sentient AI demands a precautionary principle, questioning the ethics of creating beings potentially subject to mistreatment. This challenges anthropocentric morality, forcing us to define the basis for intrinsic worth. Is it biology, subjective experience, or another criterion? It represents philosophy's frontier with computer science. In this lesson, we will learn about the key structures for implementing ethical AI. Let us start. This lesson examines key structures for implementing ethical AI. We progress from broad policy to practical tools, then review organizational accountability and the global ecosystem. We will discuss the regulatory landscape, tools for practitioners, organizational structures, and the role of open source standards and international cooperation. Let us start with the first one, that is the regulatory landscape. On the left, you can see a table which discusses the different unions with its philosophical approach as well as the key regulatory and the core focus. Beginning with the European Union, the EU AI Act, you must have heard about this. It is a risk-based approach categorizing AI by 4 levels, from prohibited to minimal risk, with strict compliance rules for high-risk systems. The next one is for US, that is NIST, AI, RMF and executive actions. A voluntary framework for risk management paired with a sectoral enforcement model where existing agencies oversee AI in their domains. The next one is United Kingdom, that is UK. It is a principles-based approach which is context sensitive, that leverages existing sectoral regulations without new AI legislation. Next comes for China. It combines algorithmic transparency rules, data security laws and content specific management. The last one is Canada. It is a legislation targeting high impact AI systems. This is done to ensure safety and human rights for automated decision making. Global AI policy is shaped by 2 policies, the pro-innovation approach and the precautionary principle. The pro-innovation approach fosters growth with minimal new laws, and the precautionary regulates based on potential risk. This tension defines worldwide regulations. The EU AI Act exemplifies the precautionary principle, while the US NIST framework represents pro-innovation. On the left, we saw the regulations of AI worldwide. The second one includes the tools for practitioners. Operational tools help implement ethical principles, beginning with AI auditing and checklist. Systematic reviews assess compliance, fairness and function. These evaluate data quality, model fairness, explainability, security and governance. Red teaming, proactive security testing where a team simulates attacks to find system vulnerabilities. The process involves planning, execution and reporting stages. Impact assessments, pre-deployment analysis of potential impacts on rights, safety and society, mandated by regulations like the EU AI Act for high-risk applications. The third includes organizational structures. Formal accountability is required to embed ethics. It includes the ethics boards and chief ethics officers. A dedicated executive or body creates and enforces guidelines, resolves dilemmas, and ensures alignment with principles. Next, whistleblower protections. Safe internal channels for reporting unethical practices are essential. The EU AI Act mandates such tools for secure reporting. Next, clear accountability frameworks. Organizations must predefine responsibility, assigning clear ownership for each AI model and decision to specific individuals or teams. The last one, that is the role of open source standards and international cooperation. Global ethical AI relies on collaboration beyond compliance, beginning with open source dual role. It enables sovereign AI, providing transparency and control for independent development. A 2025 survey found 90% of organizations view it as essential for this goal. Next, standards for interoperability. Shared technical standards ensure AI systems are robust, evaluable, and can work together across borders, reducing market fragmentation. Next includes international cooperation. Despite regulatory differences, 94% of organizations deem global collaboration essential. It can focus on shared research, principles, and metrics to address universal challenges. So let us see the key takeaways and case studies. Consider these tensions and examples to connect the concepts. The first, flexibility versus certainty. The US and UK models offer flexibility for innovators, while the EU's detailed rules provide legal certainty. Next, let us quickly see the case study for Compass algorithm. This US justice system tool used to predict recidivism sparked a fairness debate. Developers argued it was equally accurate across races, while investigators found it disproportionately labeled black defendants as high risk. This highlights a conflict between technical fairness and societal equity. So in this lesson we saw the key structures for implementing ethical AI. In this lesson we will discuss about the governance and practical structures to implement ethical AI principles. Let us start. Consider this lesson as the capstone of our AI ethics course. This capstone lesson connects ethical concepts with practical action that will focus on participatory design and inclusive features, then cultivating an ethical mindset, and in the final project we will develop an AI ethics charter. On the left, a table is visible. The table summarizes the core themes, culminating in a final project to create or analyze a real-world charter. We will begin with the participatory design and inclusive features. Its core concept empowers diverse stakeholders to co-create systems, not just consult them. Next, we will discuss cultivating an ethical mindset that embeds ethical responsibility into organizational culture. It develops governance that turns principles into enforceable practices. In the final project, we will create a living governance document synthesizing core concepts. It will synthesize all lesson topics serving as the tangible course outcome. That is the tangible synthesis of all the topics. Let us start with the participatory decision and inclusive features. Ethical AI requires involving affected people in its design and governance. Beyond consultation to empowerment, current practice often merely consults stakeholders on predefined choices. True participation means empowering them to shape core system decisions. It also includes a framework for meaningful participation. Move beyond tokenism by designing participation across 4 dimensions. That is why, what, who, and how. Why define the goal as instrumental or normative? What is to determine what is the scope, that is to determine which aspects stakeholders can influence. Who, involve the community in selecting representative, prioritizing marginalized groups. How, that is the method. Use co-creation methods and ensure equitable safe spaces for interaction. Here is the proxy trap, using stand-ins for stakeholders risk misrepresenting their true needs and values. The second one is cultivating an ethical mindset. This focuses on moving from abstract principles to an ingrained organizational culture. This begins from individual to organizational ethics. Scale ethics from practitioners to the entire organization via clear accountability and enforceable governance structures. Next includes operationalizing principles, that is to translate principles into concrete actions including fairness, transparency and accountability. Fairness means to implement bias audits using diverse metrics. Transparency means adopt explainable AI and document limitations. Accountability means to assign clear responsibility for each AI system's lifecycle. The last one is leadership and culture. Leaders must bridge core values with technical requirements, fostering a culture of ethics through collaboration, training and aligned incentives. Now let us see the final project, that is developing an AI ethics charter. This project synthesizes your learning into an actionable document, a formal charter committing an organization to responsible AI. Your charter should include preamble and purpose, that is to state the organization's mission and the charter's goal to ensure AI serves people, society and the planet. Next, the core ethical principles. This is to declare 5 to 7 foundational principles such as human oversight and control, fairness and inclusiveness, transparency and explainability, privacy, security and robustness, accountability, and in the end, the societal and environmental well-being. This includes that AI should augment human judgment, it should reduce bias and promote equity. You should commit to clarity about AI capabilities and decisions, protect data and ensure reliable systems, establish clear responsibility for AI outcomes, and consider broader impacts and sustainability. The third one is governance structure. Describe how the charter will be enforced, beginning with AI Governance Committee, a cross-functional team to oversee strategy and review high-risk projects. Clear roles and responsibilities. Define accountability for auditing, risk management and incident response. Risk management process. Integrate a framework like the NIST AI RMF to mitigate risk throughout the AI lifecycle. The last one is implementation and lifestyle practices. Outline procedures to enact principles. It includes participatory design protocols, that is to involve diverse stakeholders in the design process. Ethical impact assessments. Conduct mandatory assessments before, during and after deployment. Training and awareness. Educate all employees on the charter and ethical principles. Auditing and transparency reports. Perform regular audits and public reporting on system performance and compliance. So in this lesson we saw how to connect ethical concepts with practical actions. We also saw a project to develop an AI ethics charter. In this lesson we will cover a case study related to Amazon. It will help us to understand AI ethics. Let us start. In late 2025, over 1,000 Amazon employees released an open letter criticizing the company's rapid AI rollout. The case highlights a breakdown in participatory design. Those impacted by the tech had no real input. So let us cover this through the ethical principle, beginning with the inclusive futures and stakeholder involvement. Employees were pushed to use internal AI tools to double output, yet had no role in their creation. They called for ethical AI groups with frontline worker participation. This matters because a strong AI charter must ensure diverse employee voices are formally included in decisions about AI design and workplace integration. The next principle is ethical mindset and organizational culture. Workers described a fearful environment where AI concerns were silenced. AI was linked to layoffs and pressure for non-stop productivity. It matters because a charter must shape culture, not just tech. It should protect whistleblowers and ensure AI supports, not exploits human labor. The next principle is accountability and governance. The letter demanded oversight, criticizing leadership's reckless, unchecked AI expansion. It matters because a charter needs enforceable governance like a cross-functional ethics board to evaluate and slow risky AI deployments. This case shows that ethical failures go beyond biased algorithms. They include harmful implementation that overlooks worker input and well-being. Let's see how we can connect this to our final project. Use this case to support your proposals, that is justify participatory design. Point to Amazon's example to argue for worker councils or stakeholder panels when AI alters workflows. Mandate transparency. Use the case to require that AI decisions be documented and understandable to those affected, not just engineers. These points highlight that AI ethics remains a pressing unresolved issue. In this lesson, we saw the Amazon's AI ethics case study. We tried to understand the main issue in it. In this lesson, we will understand a case study related to Uber's AI-driven pay systems. Let us start. In November 2025, Worker Info Exchange filed a legal demand against Uber's AI-driven pricing system, claiming it cut driver pay and breached European data laws. This case directly ties to fairness and transparency principles discussed in our course. Let us see the ethical principles involved. First one being fairness and non-discrimination. Let's see what happened. Oxford research showed drivers earned much less per hour after Uber's AI pay system launched, while Uber's share increased. The algorithm used drivers' past data, possibly locking them into lower earnings. Why it matters for an AI charter? Charters must require impact assessments for AI systems that distribute pay or benefits. Regular fairness audits, not just efficiency checks, should be mandatory. The next ethical principle is transparency and explainability. The lawsuit highlights how Uber's dynamic pricing lacks clarity. Drivers couldn't understand how fares were set, prompting calls for human oversight. Let's see why it matters for an AI charter. Charters should guarantee the right to a clear explanations for algorithmic decisions. Drivers must know what factors influence their trip fares. The last one, that is the human oversight and accountability ethical principle. The legal demand seeks to restore human oversight, arguing that fully automated pay decisions are unlawful and harmful. Let's see why it matters for an AI charter. Charters must identify high-risk uses like wage setting, where automation is banned and human review is required before final decisions. This case shows how algorithmic systems can cause real harm when fairness and human welfare are overlooked. Let's see how to connect this to your final project. Use this case to support your proposals with timely, concrete examples. The first one being enforce fairness audits. Cite Uber to justify third-party reviews of AI systems that control pay, promotions or resources. Mandate transparency. Use the case to argue that AI decisions must be documented and explainable to those affected, not just engineers. These points show that AI ethics remains an urgent unresolved issue. So in this lesson we covered the Uber's AI-driven case study that reflects pay systems and legal action. Guys, if you liked the video, you can directly go to our channel and support us by subscribing and joining. Click on the join button. Herein you can support us, okay, by clicking join here. And you can also go to any of our video, okay, herein click on the three dots and click thanks. You can also directly support us here, okay. Thank you for watching.